Hello everyone. I hope I am audible right now. Stream start हो गई होगी. And today is our day 7 of our streak. कल actually stream मैंने इसलिए नहीं किया क्योंकि अब भाई मेरे को hash mark थोड़ा hard लग रहा था. But so instead of that, hello everyone. What we did is I hope I am audible right now. We solved a question. It was a good question with help of my roommate. Like 2 pointer का concept उसमें लग रहा था. That's why I need to took help. But it's fine. I'm thinking of कि हर रोज मैं एक क्वेश्चन तो सॉल्व करूँ ऐसा लाइक रिगार्डिंग कुछ भी हो भाई इजी वगैरह क्योंकि बट आई हैव ऑब्जर्व कि आई कैन नॉट सॉल्व क्वेश्चन. हम्म. हम्म. हाँ.
अरे वाह ड्राइवर.
हम्म.
the character, but it auto casts itself into an integer. Got it?
बोलत कोणाचं होत होतं?
लाइव स्ट्रीम कर देना.
अरे वाह.
So this is a character s of I, but the hash inside its brackets needs an integer. So even if you write a
जीरो ऑफ कोर्स बोनस नहीं वॉच कर दे फोन करना रे.
character, it will auto cast itself to its integer value, which is the ASCII value. This is why. So coming back to the problem that we had in number hashing. So in number hashing, when we were trying to hash it into the
क्वेश्चन
arrays,
करते हैं
we saw that we can at max do it
हैशिंग एनी अनऑर्डर्ड मैप.
Time complexity for searching.
सर्चिंग मध्ये
मॅपसाठी
हॅश मॅप साठी फॉर लूप एक लागतं. वाईल लूप तर एकच लागला मग वन नाही. एक मिनिट. बिग ऑफ एन स्क्वेअर एन.
वन. कारण तुला जर स्पेसिफिक की माहिती असेल तर
हम्म.
आपण जस्ट ट्रॅव्हल्स करायला वापरलं. तुला जर स्पेसिफिक की माहिती असेल त्या की नंतर तू व्हॅल्यू काढू शकते.
आणि माहिती नसेल तर
माहिती नसेल माहिती लागणारच.
ओके.
ट्रॅव्हल्स जर करायचा झाला तुला ते ट्रॅव्हल्स करायला
हम्म.
पूर्ण ह्याच्यावर बिग ऑफ एन ट्रॅव्हल्स करायला आणि जर तुला पर्टिक्युलर एलिमेंट फाइंड करायचं झालं तर तुला की माहिती आहे ॲरेचा इंडेक्स जर तू टाकलास बिग ऑफ वन वरून आपण
लगेच व्हॅल्यू
फेच करतो ना.
आहे तो बरोबर आहे. आहे ते
आयडियल असं बिग ऑफ वन आहे ॲरे मॅप बिग ऑफ वन सेट नाही सेट
बिग ऑफ वन. हा यार मी लूप बघतो यार लाईक काय चुकीचं बघतो मी नाही का की जेवढे लूप आहेत तेवढे टाइम कॉम्प्लेक्सिटी.
ते आहे बरोबर. पण ते नंबर ऑफ एलिमेंट्स ते प्रोग्रामचा टाइम कॉम्प्लेक्सिटी झाली.
फक्त हॅशिंग कन्सेप्टचं असं म्हणतो का?
हॅश मध्ये तू जर टाकला एलिमेंट आणि तो जर तुला पर्टिक्युलर एलिमेंट गेट करायचा आहे
मग
तर
वनच
बिग ऑफ वन.
येते वनच येते राईट तो बरोबर आहे.
आणि इंटरव्ह्यूवर तुला हे विचारणार मग त्याचा मोठं तो असणार कोणता वापरशील किंवा काय एखादा प्रश्न असा टाकेल की त्यात तू बाबा हॅश मॅपच का वापरलं तुला सांगता आलं पाहिजे की बिग ऑफ वन प्रोव्हाइड करते.
टाइम कॉम्प्लेक्सिटी बेटर आहे त्यामुळे.
कारण आपण हॅश मॅप असा आयडियली क्वेश्चनला सपोर्ट म्हणून वापरतो. सपोर्ट डाटा स्ट्रक्चर म्हणजे एखादा प्रॉब्लेम आहे तर तू तो हॅश मॅप मध्ये हे करून वापरून
त्यातली इन्फो घेतो आणि दुसऱ्या कोड ऑफ पार्ट मध्ये यूज करतो.
असं त्याचे मेथड्स आपण वापरतो त्याच्यात असं सांगू काय
चालतंय. मला समजा डोक्यात ते वनचं लॉजिक कळालं मला.
till 10 to the power 7.
त्याचा ऍडव्हान्टेज आहे.
That also if we declare the array globally. And for numbers exceeding 10 to the power 7, like 10 to the power 9 or 10 to the power 12 or 10 to the power 18, we cannot hash it using arrays. That is not possible. This is something that we need to solve. And that is where in C++, STL comes in. If you have not seen the STL video, please go back and watch it. And in Java, the collection comes in. So in STL, there are two things. One is the mapping, while the other one is the unordered map, which I'll be talking in depth. And most of the concepts that I'll be talking about map and unordered map also apply to the hash map. It is just the same stuff, just the writing format is different. And the concept inside it is the same. So let's understand map and unordered map. So till now, we were taking an array, right? If you remember, we took an array of size 13 and then we hashed it. And in C++, let's talk about map. So what happens is, imagine you're given an array, something like 1, comma 2, comma 3, comma 1, comma 3, comma 2. Imagine you're given something like this. So in C++, what happens is, map is a data structure. So I'll just represent this with a bucket as well. So what you do is you say, okay, I know there has to be a key. What is a key over here? So this is the key. The number is the key. So the number is the key, remember this. And there has to be a corresponding value to it. And the value over here is the frequency. So this is how it is defined. You basically say, okay, what is
वो ऑफन अनऑर्डर्ड मैप्स है माती सवय लागली रे ते फॉर लूप त्याने हॅशिंग त्याने सोपा प्रश्न विचारलेला जसंच तो वन म्हणला ना मग मला लगेच लक्षात आलं वन कसं आहे कारण आपल्याला येऊन सिंगल याची क्वेरी विचारून हे करतो
your key? Is your number. How many times it appears is the value. This is what you do. As simple as that. So what I do is, okay, I know one thing. At the first step, I have one. So I will say, can you go ahead and if remember one thing, before iterating in the array, if you say MPP of 1, this will return you 0 because it doesn't exist in the map. So the value, the corresponding value will be 0, right? So the moment you go to 1, you say MPP of 1 plus plus. So what will happen? If will return you, go ahead and if remember one thing, before iterating in the array, if you say MPP of 1, this will return you 0 because it doesn't exist in the map. So the value, the corresponding value will be 0, right? So the moment you go to 1, you say MPP of 1 plus plus. So what will happen? If it doesn't exist in the map, it will go to the map and say, 1, you do not exist. It's 0. It's 0. 0 plus plus is 1. So it will store a key value. Key mapped to a value of. Next, it goes to 2 and does a map 2 plus. And it sees it doesn't store 2. So what happens is, it goes and stores 2. Next, it goes to 3. Again goes and sees doesn't stores 3. So 3 plus plus. Next is goes to 1 and sees, okay, I already have. Let's go back to that 1 and say, can you please increase my value? So it just increases its value to 2. Next goes to 3, again increases its value to 2. Next goes to 2, again increases its value to 2. So what you need to do is MPP of array of I plus plus. That's what you need to do. And imagine, I'll just erase this. Imagine I had a number like 12. Then what would have happened? So you would have done MPP 12 plus plus. So 12 would have gone as 1. Quite simple. Very, very simple. So something to observe. Over here, even if the number was still 12 and you would have used array hashing, you would have ended up taking a size 13 array in the array hashing. And over here, how many elements? Size 12. And you something to observe. Over here, even if the number was still 12 and you would have used array hashing, you would have ended up taking a size 13 array in the array hashing. And over here, how many elements are you storing? We're just storing the elements that are required because you require 1, 2, 3, and 12. So 4 elements are stored. Whereas in array hashing, you had to declare a 13 size array if the maximum was still 12 in order to get the 12th index. So this is where map is slightly beneficial. It takes a little less memory because it will just store the elements that are required. If you do for MPP of 4, it is not there in the map. So it will automatically throw you a 0, but it doesn't stores 4. It doesn't stores 4. Got it? So if I go back to the code, you see that you have stores 4.
So he right now told us कि unordered map के लिए. So this unordered map thing, let me see. So unordered map क्या करता है कि अगर हमने एक एरे बनाई है तो एरे में फर्स्ट एलिमेंट पे जाएगा, जैसे 1 है, उसको एक की देगा एंड उसकी वैल्यू उसका काउंट स्टोर करेगा. ठीक है, जैसे ये 1 है, ये 1 ही मेरा की है और उसकी रेपिटेटिवनेस उसकी वैल्यू है. फिर आएगा 2. सेम, अब इसका की है और इसकी रेपिटेटिवनेस है 1 है. ठीक है, 3 के लिए भी इसने 1 किया. अब 1 पे आएगा, 1 पे जाएगा ना वापस, ये इस की पे जाएगा 1 वाली, एंड इसको 2 करेगा. रीजन बिंग क्योंकि 1 एक ऑलरेडी मिल गया है तो ये 2 कर लेगा. फिर ये 3 एंड ये अगेन 2 कर लेगा. अब 12 के केस में क्या होगा, 12 और 1. एंड जो वो एरे बनाएगा वो n इक्वल टू 13 के होगा. मैप खुद से एरे बना लेगा. तो बेसिकली ये एक पार्ट ऑफ कोड यूज़ करना है. हम्म. सो द नेक्स्ट थिंग इज, हाँ, कि की एंड वैल्यू का कंसेप्ट ये नंबर है और उसकी फ्रीक्वेंसी है. गॉट इट. हाँ, उसके बाद इसने एक और चीज़ ये बताई कि हाँ, यही कि एरे जो है ये होगा. और हाँ, और ये गार्बेज वैल्यू स्टोर नहीं करते. जैसे एम पी पी 5 तो है ही नहीं ना इसमें, तो उसको एज ए ज़ीरो ही रिकॉग्नाइज कर लेगा. गुड वन.
It doesn't
अभी लिखो या बाद में लिखो भाई? बाद में
stores 4.
इतना कोड
Got it?
लिखता हूँ.
So if I go back to the code, you see that you have an n, you have the array, you have the queries, and then you have all the queries. So it's quite simple. You say n, you say scene of n, and then you say int array of n. Then you say for int I equal to 0, I lesser than n, I plus plus. And then you go across and say, let's take these arrays, values, array of I. And now you need the queries. So let's take the queries, int q, scene of q, and now you do while q minus minus, and then you take the number and you take number over here and you say see out. This is where you fetch. So you
इस बार हम फेच करते टाइम मैप फेच करेंगे.
pre-compute here and then you fetch it over here. So we have to do the pre-compute. So what do you do is map of key, and you know the key is a number which will be integer. If the number goes till like 10 to the power 9 or 10 to the power 12, then you could also go ahead and take along, because 10 to the power of key, and you know the key is a number which will be integer. If the number goes till like 10 to the power 9 or 10 to the power 12, then you could also go ahead, depending on the size, take along, because that will be bigger numbers, or you can take long as well. Depending on the size of the numbers, you can define int I equal to 0, I lesser than n, I plus plus, and you say map of array of I, and you do a plus plus. Quite simple. And in order to fetch it, and once you've done this, you can go ahead and say, can you please run this? And if you run this, you will see that everything is fine. 4 appears 0. That's why.
अरे भी हम नंबर ऐसे थोड़ी ना लेते हैं यार, कम ऑन। अरे हम लेते हैं नंबर ऐसे। अरे मतलब फॉर लूप, अरे मतलब फॉर लूप, अरे मतलब फॉर लूप। अरे
ट्वेल्व पे
ठीक है, नेक्स्ट प्री कंप्यूटेशन हम बाद में करेंगे, पहले हम ये करते हैं। पहले अब हम करेंगे कि बेसिक क्वेरी लेंगे हम, कि हमें यूजर से कितने क्वेरी लेना है। अरे कैर भी नहीं भाई, टीना। हम्म, अब यहाँ पे ये इम्पोर्टेंट पार्ट है, ये हमारा प्री कंप्यूटेशन पार्ट है बेसिकली। सो दिस वन सेज कि हमें क्या करना है, सबसे पहले मैप लगाना है। मैप कैसे लगाते हैं हम, इंटेंट, है ना, इंटेंट। ठीक है, एज पर हिज कोड, किधर है ये बंदा। हम्म, मैप इंटेंट, और हम एमपीपी को उसको नाम क्या देना चाहते हैं। फिर हम फॉर लूप लगाएंगे एक। ओके। So yeah, this is it. कि suffocate इस VS में एक प्रॉब्लम है कुछ तो यार। कोड चेक के कंपाइलर में जाओ क्या यार, क्या भाई, हट। व्हाट इज दिस भाई, कम ऑन। ऐसे कैसे जीरो आ सकता है यार। मेरे को शायद ना भी VS कोड में करना स्टार्ट करना चाहिए। इसका भी सेम प्रॉब्लम है पता है। वेयर इज इट, सी प्लस प्लस में करना है ना हमको। कहाँ डिफाइन हुआ है मेरे। अरे यार ये हटा हुआ है, इसको क्या है ये। रन करो अभी। मैप डिक्लेयर नहीं किया। ऐसा ऐसे भी करते हैं क्या। क्या दिक्कत हो गई मेरे भाई यहाँ पे। कम ऑन यार, इतना इतना भी मुश्किल थोड़ी ना है, कम ऑन। अरे यार शिट, सही बोला वो, हट मैं भी ना, कहाँ ध्यान होता है मेरा, पता नहीं। इज इट विजिबल ऑन स्क्रीन? विजिबल है हाँ, यहाँ पे एमपीपी आएगा यार, कम ऑन। यार इसका इनपुट का कोई दूसरी विंडो है क्या? क्योंकि ये मेरे से बस इनपुट ही मांग रहा है मेरे भाई। अच्छा ये 4, क्वेरी मैं 2 ही लूँगा, इसमें मैं 3 और 4 पूछूंगा, 2 और 1। अच्छा अच्छा अच्छा, तो इसको ऐसे वर्किंग है यार, इस पे क्या दिक्कत आ रही है? इतना अच्छा तो ये सॉफ्टवेयर बना के रखा है इन्होंने, ये भी नहीं चल रहा, तो मैं क्या करना है? ऐसा तो नहीं कि फाइव के बाद फिर मेरे को सीधा, या फिर ऐसा तो नहीं मेरे को फाइव करना है? न्यू लाइन पे कैसे जॉब है? मैं ऐसे तो मेरे को समझ गया कि प्रॉब्लम क्या है। 1 1 2, क्वेरी में 2 ले रहा हूँ, 1 और 2 की। ना इसमें दिक्कत है, छोड़ो। बट मेरे को इसको ऑन ऑन तो करना ही पड़ेगा, क्योंकि मेरा मेन कोड यही पे रन हो रहा है। एक यहाँ पे ट्रैक रहेगा भाई मेरे कोड्स का थोड़ा बहुत।
PS1s, it does run fine. So remember one thing, the map stores all the values in sorted order. This is something which you have to keep in mind. The map stores all the values in sorted order. What does that mean? This will be at the first place in the map. This will be at the second place. This will be at the third place. This will be at the fourth. How can I prove it? What I'll do is I'll go ahead and say, let's iterate in the map. So if you just iterate in the map, this is how you iterate in the map, an auto iterator on the map. And if you do cout of it dot first, up something like this, and do it dot second, this is how you can get it. So if I just try to run this, you will see what will happen. Before printing all of this, it actually shows you one appears twice, and this is how it is. This it dot first, up something like this, and do it dot second, this is how you can get it. So if I just try to run this, you will see what will happen. Before printing all of this, it actually shows you one appears twice, and this is how it is stored in the map. So this is how you can also I you pre-compute the map.
अविनाश, आइटरेट करणं म्हणजे काय असतं? म्हणजे त्याला आइटरेट म्हणतात, ओके. ओके फाइन.
So let's quickly comment for taking the input and then doing the pre-compute. You can also do this over here. It is, and you can just like you can declare this before this, and itself, and you can just omit. The pre-computation can be done while taking the input as well. It doesn't matter. It will save you one for loop, but that is okay. That won't change anything, or that's n plus n. Your program super fast. Why won't it make super fast? Because it's n plus n and not n into n. N into n generates a bigger value. N plus n is like 2n. And if you remember the time complexity, we ignore 2, 3, and all these smaller values. Remember? So we did learn about map. Can this map be used in something else? Yes. You can also use map in string hashing. Now, what is the key over here? If you remember, the key is a character. So what you can do is you can say map of character and store its frequency. So instead of using an array for hashing, you can go ahead and say map of character. And now you can say map of whatever is your character s of I plus plus. This will not be converted into integer. Now your map will be storing something like this. A appears twice, B appears once, C appears once. So depending on what you are trying to hash, that will become your key. And what are you storing? That will become your value. Over here, we are storing the frequency. That's why it's string plus plus. Got it? In Java, so in Java, there is something as hash map. You can use it. It works in the similar fashion. Now let's talk about something very important. What is the time complexity of this map? So in order to do something like map, it's got it. Over map will be storing something like this map array for hashing. Remember the key is a map 2, 3, and all these smaller values. Remember? So we did learn about map. Can this map be used in something else? Yes. You can also use map in string hashing. Now, what is the key over here? If you remember, the key is a character. So what you can do is you can say map of character and store its frequency. So instead of using an array for hashing, you can go ahead and say map of character. And now you can say map of whatever is your character s of I plus plus. This will not be converted into integer. Now your map will be storing something like this. A appears twice, B appears once, C appears once. So depending on what you are trying to hash, that will become your key. And what are you storing? It's string plus plus. Got it? In Java, so in Java, there is something as hash map. You can use it. It works in the this map. Now let's talk about.
Let me write this one. और क्या कर रहा हूँ मैं ADHD वाली हरकत anyways where was I yes this one so what we learned is this new part of the code भाई हमारा इम्पोर्टेंट तो बस इतना ही है चल यार एक्चुअली तो so this is it Hmm. मैपिंग में एक होती है की, एक होती है वैल्यू। सो जो प्री कंपटीशन वाला पार्ट आएगा, तो ये इम्पोर्टेंट पार्ट है। और लास्ट में फिर वाइल वो सबके बीच में आएगा हमारा सी। अच्छा, ऐसा तो नहीं कि यहाँ पे एरर था इसलिए वो रन नहीं हो रहा था। आई डोंट थिंक सो। एमपीपी होगा भाई तो आप। वो तो ऐसे भी रन नहीं हो रहा था मेरे भाई पर, कम ऑन। वैसे भी रन नहीं हो रहा। एक्स्ट्रा आइटरेशन जो हम कर रहे हैं, सो फॉर ऑटो आइटरेटर एमपीपी।
About something very important. What is the time complexity of this map? So
बंदी होगी।
in order to do something like map of something plus plus,
Peak
that is
of one।
basically storing in the map. You have to fetch from the map, that is MPP of, you're doing array of I or something like this.
Right.
So that's fetching from the map. The storing of fetching. Remember this. Storing of fetching. Logarithmic of n of them in a map. In a map takes logarithmic of n. Takes logarithmic of n in all cases. In best, in average, in worst. In all cases, takes logarithmic of n. Remember this. But there is something as unordered map. There is something as unordered map, which we will be talking about now. So let's go back to the code. So even if I write this unordered, will it run? And if I go ahead and run this, it will actually run. You see the values are getting printed. So even if you take unordered map, it does run. Now, what is the meaning of unordered map? So as the name recommends, unordered. So imagine now I go across the map and try to print it. So if you remember in the map, it was storing everything in this sorted fashion. But over here, by the way, just my bad. Let's comment this off. In the map, everything was stored in the sorted order. But over here, if you see, there is no particular order. There is absolutely no order. It can change on every program. Like over here, it's 312 to 1. If you run it, if you run the same code on some other compiler, it might be having some different order. So the order is something which you cannot decide. So as the name recommends, it is unordered. But then you might ask, what is the advantage of using this? Let's talk about this. When you are storing something in the map, which you are doing, and when you're fetching in the map, the average and the best time complexity is a constant one. The average and the best is average, like in most of the cases. In most of the cases, it will be big O of 1 for storing and fetching. But there is something as the worst case, and that ends up taking linear time. Linear time. What do you mean by linear time? This is nothing but the number of elements in the map. This is nothing but the number of elements in the map. When I talk about n, if I'm talking about log n, This is nothing but the number of elements in map data structure. Depending on the number of elements, the time will be computed. So the average in the best case will be big of 1. In most of the cases, it will be big of 1. In very minor cases, it will happen once in a blue moon. If the problem setter is extremely like he just wants to make your code fail, he might end up giving a worst case that might end up taking big of n, and your code apparently will take n squared. Because imagine if this line is taking big O of n and you're running a loop over it, so it's like n and this is n. So n into n happens. But if this line is big O of 1, then it becomes n into 1. Most of the times, what you need to do is you need to use unordered map. Yes. If it fails, if it gives you a time limit exceeded, that means taking a lot of time, then you switch back to map. But the first preference should be unordered map, because the worst case very rarely happens. I know it is a worst case, but it very rarely happens. Why does the worst case happens? Because of internal collisions. Because of internal collisions. So since we are talking about collisions, why does the difference and the case that one is computed? But there is something as the worst case, and that ends up taking linear time. Linear time. What do you mean by linear time? This is nothing but the number of elements in the map. This is nothing but the number of elements in the map. When I talk about n, if I'm talking about log n, this is nothing but the number of elements in map data structure. Depending on the number of elements, the time will be computed. So the average in the best case will be big of 1. In most of the cases, it will be big of 1. In very minor cases, it will happen once in a blue moon. If the problem setter is extremely like he just wants to make your code fail, he might end up giving a worst case that might end up taking big of n, and your code apparently will take n squared. Because imagine if this line is taking big O of n and you're running a loop over it, so it's like n and this is n. So n into n happens. But if this line is big O of 1, then it becomes n into 1. Most of the times, what you need to do is you need to use unordered map. Yes. If it fails, if it gives you a time limit exceeded, that means taking a lot of time, then you switch back to map. But the first preference should be unordered map, because the worst case very rarely happens. I know it is a worst case, but it very rarely happens. Why does the worst case happens? Because of internal collisions. Because of internal collisions. So since we are talking about collisions, let's understand how does hashing work. Because if you remember, I told you that the moment it crosses 10 to the power 7, an array hashing cannot be done. So how is a map data structure created? Will someone ask you? Might not. Like in interviews, they generally don't ask that much. Even if they ask, only telling them about division method will work. These two methods are something which you just need to know the names. Might come up in your semesters, but this is the method that you have to understand. So how is the internal map designed? Because if I'm talking about design, I know I can design an array hash. But for numbers like 10 to the power 18, how do I store it? This is where internally you might see like these map data structures are implemented in different ways. They might be using division method. They might be using folding mid square. They are implemented in a very complex way. You don't need to know it. But let's understand what is the division method. Because if I take the division method, then I might be able to explain you what is collisions. So let's understand the division method. So imagine, I'm giving you numbers like, in an array, I'm giving you numbers like 2, 5, and then 15, and then 55. Not 55, not 15. Let's take 16, 15, giving you the, and then 55, not 55, not 15. Let's take 16, and let's take 28, and let's take 139. Okay, so these are the numbers that I've given. So you can do array hashing, because I'm not talking about map. If you have to do array hashing, you can actually go ahead and create an array of size 140, where you go like 0, 1 until till 139, because if you create an array of size 140, you'll get 139, and then you can hash it. But imagine, I tell you, you cannot create an array for a time being. You cannot create an array of size greater than 10. This is not allowed. An array of greater than size 10 is not allowed. I'm taking very smaller values in order to explain. You can map this to bigger values. So you can map this to the bigger problem that we're trying to solve. In the bigger problem, imagine you have number like 100, 10 to the power 18, and then 10 to the power 16, and then 10 to the power 4. And the maximum size allowed is 10 to the power 7. Beyond this, it's not allowed, right? So it's the same problem we are solving. We have bigger numbers, but as of now, we have a restriction that you cannot create an array greater than size 10, greater than equal to, like at max 10 is allowed, not more than. How will you do it? So this is where something like a division method comes in. Yes, this is where something like a division method comes in. What does division method say? Division says, okay, I just have 10 size array allowed, which means I can only store 0 to 9, right? So it's like 0, 1, 2. So as I said, an array of greater than size 10 is not allowed. So this is what we can have at max. So 0, 9. And we will be using the division method in order to hash it. How will we use the division method? It's very simple. If we have 2, whatever number we have, we will try to modulate it with 10. So for 2, the corresponding value will be 2. So I'll go to 2 and I'll say it appears 1. For 5, I'll modulate it with 10. I'll get 5. I'll modulate with 10 and I will get something like, what will I get? I'll get 8. Right? Now what I do is, I have used the division method to kind of trim down the number and have been able to somehow array hash it. Right? So this is what the division. But your brain might be thinking a lot of things. I'll come to that one. Don't worry. So this is how the division method works. Now, if someone does ask you, and someone just comes up and asks you, hey, how many times 139 appears? So you say 139 modulo 10 is equal to 9. What is the value at 9? It's 1. So it appears 1 time. That's how you retrieve equal to 9. What is the value at 9? 39 appears. So you say 139 modulo. That's how you retrieve. The division method is modulo 10. So that's how you put it, and that's how you retrieve it. So that's how you trim down the number. Now you might have a lot of questions. I'll come to each of these questions now. Now what I've done is I have kind of drawn the array in the vertical. Come to you division and division. So 0 is 9 size. What does division method say?
Okay, so he's telling कि हैशिंग के अंदर होती है हमारी डिवीजन मेथड वगैरह होते हैं, लाइक कोलिजन है ना, उसे एक्सप्लेन करने के लिए. So yeah,
A division is one method number corresponds with array hash. Thinking a lot of things. I'll come to that one. Don't worry. So this is how the division method works. Now if someone does ask you, and someone just comes up and asks you, hey, how many times 139 appears? So you say 139. That's how you retrieve. The division method is might have a lot of yes. So you say 139 modulo. That's how you trim down the number. Now you might have a lot of questions. I'll come to each. And the first question that might come to your head is, what if on modulo 10 they are same numbers? Because this is 2. We have 5 numbers. In some chaining. This is what you call as, so I'll probably store the numbers. In some chaining. This is what you call as linear chaining. Again, these things will be done using linked list. You don't need to know, just understand the logic and concept. 28 modulo 10 is 8. So in 8, you put 28. 139 modulo 10 is 9. So in 9, you say 139. 38, here comes the collision factor. This was also modulo 8. This was also modulo 8. So you cannot store. So you chain it. You say, I have one more 38. Next, 48. Again, you do a modulo 10 and you get 8. So you go and say, chain it. And this time again, you get 8. But this time you get 28. You chain it. But you do not chain it in the back. Instead of that, you chain it somewhere like this 28 and back over here. And you kind of break this. This is something which can be done using linked list and in a very simple way. You'll be learning this in linked list. So you chain it. 28 is there twice. And then again, you get 18. So you chain it something like 18. And then you make 28. It's like 18, 28, 28, 38, 40. You chained it, right? So this is how it works. Now, if someone does comes up and asks you how many times 28 appears, so what we do is we say 28 modulo 8, we go to 8 direct, and we know there will be limited numbers, and we know it is sorted. So there are a lot of search algorithms which are applied internally, and you can easily do a binary search on, and you'll find that there are two numbers, and it can be done in minimal time. Minimal time. Got it? So this was the division method that I did talk about. So you can do some chaining and you can keep it in certain ways. Imagine you had 22, then this will be chained here. So chaining can be done, and you can always keep them in limited memory storage. So do you need to implement this? No, you just need to understand the concept. What then? But Shrev, then what is collision? So in order to find out how many times 28 appeared, what did you do? You just went to 8 and then you figured out 28 appears twice because it was chained in a sorted order. Because it was chained in a sorted order. So it is quite easy to find out 28 twice. But if just realize this 8, this chain would have been ultra huge. Do they use the division method internally? No. They use some method which is a mixture of everything. Depending on the input, they find out some method and they use it. Imagine they're using a method internally which falls under collision. What is collision? You're given an array. Imagine they're using division. Just imagine. They're not. Just imagine. And I give you something like 18, 28, 38, 48, and all the arrays are ending with 8. So how will the chain look like? The chain will be on 8, you will have all the numbers. All the numbers. So apparently, all the other memories are not used. And in 8, you had all the numbers. It's a huge chain. Collision happened. Everyone went to the same hash place. Collision is this. Everyone went to the same hash place. If everyone went to the same hash place, you have to find it out. It's going to be tough. It's going to take a lot of time. Got it? This is what we mean as collision. Whatever hash they're using, remember this. Whatever hash they're using internally can be anything. You cannot say what they're using. Whatever hash they're using, it ends up that all your keys end up at the same hash value, hash index, ends up at the same hash index. This is when the worst case will happen and be governed. Now you understand why I said it's a very, very minor case. It might not happen. It like the problem set has to be extremely brilliant. He has to find out, and then he might be able to do it. But it's an extremely rare case to happen. This is why in interviews, when you talk about the time complexity, tell them in the best and the average, if I'm using unordered map, it's big of 1. If I go across the worst case, it will be big of n. So this is how it works. So I hope you've understood the division method. This is the normal simple division method. And linear chaining is done if there are multiple values. Folding and mid-square method collision. And in order to explain collision, then I could have explained you why big of n is such another thing. Never happens. It just happens once in a blue moon. A quick is such a like it never happens. It just happens once in a blue moon. A quick another thing. Can the key be an integer? Yes. Can it be a division multiple complexity in collision? Collision all the so which have been
कोणती? अ, हा माझी वाटतं. हा मी रे कमी वेळा घातले. हा 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 यार ही पण एक ट्रॅक पॅन्ट आहे. ठीक आहे ठीक आहे. घरी गेलो विसरलोच हे घेऊन जायचं. हे जरा टाईट आहे ना.
Ultra huge. Do they use the division method in turn? No, they use some method which in turn 8, 48, and on 8 talk about the time complexity. Tell them. In this case, it will be the normal simple do not require to explain collision once in a blue moon. Quick. Another thing. Can the key be an integer? Yes. Can it be a double? Can it be a character? Can it be a string? It can be anything. It can even be a pair of integers. It can be a pair of two guys as well. This can also be a key. Key can be anything. Any data structure can be a key in a map. But when it comes to unordered map, you can only have individual data types. You cannot say pair of int comma int to be a key and the value to be int. This cannot be a key in unordered map. In unordered map, you can only have individual data types. You cannot say pair of int comma int to be a key and the value to be int. This cannot be a key in unordered map. This cannot. But in map, any data structure, any particular data type can be a key. In unordered map, it's limited to integer, double, character, string. You cannot take like pair of int comma int or something like a vector of int. It will not allow you. Remember this in mind. A lot of you might be thinking this chaining stuff and everything. No need to worry. No one is going to ask you in interviews. It's just for understanding what are collisions. And if someone will ask you about this complexity, just for explaining. No one is going to ask you to implement this. No one. No one. Trust me on this. So coming back to the course, you can do this. Can you do this? Find the highest and lowest frequency element. I'll give you this as homework. It's quite simple. The hint is you can use map or you can use the. I'll give you this as homework. It's quite simple. The hint is you can use the highest and lowest frequency element. I'll give you this as homework. It's quite simple. On how many times they are. You can put the code in. Module is completed from the Strivers A to Z course. In the next module, we will go to step 2. So, guys, I hope you've understood everything I taught. Just in case you did, please hit that like button. And yeah, to follow our tradition, make sure you comment understood in the comments so that I get to know that you've understood everything. And if you're new to our channel, what are you waiting for? Hit that subscribe button because that is the only thing that keeps me motivated to make such kind of content. And I do get disheartened because nearly 60% of the users who watch my video do not hit that subscribe button. I know a lot of people watch videos, they do not consider hitting it. So please do consider hitting it because it does motivate me a lot. And if you haven't followed me on Instagram, Twitter, LinkedIn, all the links will be in the description. Make sure you follow me across everywhere and do share your learnings using the hashtag. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye.
हम्म Okay, fine.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this will be another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this course is India's most in-depth course on DS Algo. Why do I say that? The course has 456 modules. You can go to the market, buy any of the paid courses.
So yeah, uh, with this हमने ये वाला lecture complete कर लिया. Let's move to the sorting part now.
Check out any of the free courses. None of those courses on DS Algo will have 456 problems or modules solved. So this is definitely by far one of the most comprehensive course on DS Algo, and this is the only thing that you will be requiring if you are preparing for placements. So in the previous videos, we have covered the step 1, and now we will be going to step 2. Now the step 2 states you have to learn important sorting techniques. In order to start your journey with DS Algo, sorting is something which you have to know. Even if you're going for placements, they might ask you sorting algorithms. And the sorting 1, which is step 2.1, we have 3 algorithms: selection sort, bubble sort, insertion sort. So if you're appearing for placements, they might ask you, hey, can you please tell me the code for insertion sort? And you have to tell them, right? And sorting 2 will be based on recursion. So we'll be covering that in the next lecture. So without waiting, let's start with selection sort. So before moving ahead in the video, let me tell you about LearnBase. So LearnBase is an edtech platform that offers you data science and full stack development programs dedicated to professionals only. So at LearnBase, you will be getting to one thing I did like about LearnBase is IBM, very big session. Bangalore for also B15s have all get your free one. Does the name recommend career counseling session? The question, what is selection sort? Does the name recommends selection? What do you select?
एक मिनट guys, एक मिनट. अरे यार हट अटेंडेंस ही नहीं लगी यार मेरी. मैम ने ओरली अटेंडेंस ले लिया यार. हट, क्या दिमाग खराब है.
We select minimums. Remember this, as the name recommends. What do you select? We select minimums. So as the name recommends, select minimums. So what you will do is, you look at the entire array and you will say, who is the minimum? And it states 9 is the minimum. So you'll take that 9 and you'll place it here. Perfect. I place the 9 here. And if this 9 is the minimum and you're placing it at the first place, where will 13 go? 13 says, okay, no issues. I will go to your place because 9 has to come at first. And now I'll write the remaining guys over here. That's how you do it. So that is the step 1 of the algorithm. The step 1 states, get the minimum from the entire. And you've got the minimum. So you place it at the first. So whoever is at the first goes to that minimum. Simple as that. So swapping. Select minimums and swap
Swap it.
is what the algorithm is all about. So this is step 1. Remember this. This is step 1. What is step 2? Let's see. So the step 2 states, okay, I know the extreme smallest guy is at the first. Now we should select the next minimum. We know one thing. If the minimum is over here, this array is sorted. Which portion of the array is not sorted? That is this. Let's find the minimum. Can I say in this, 13 is the minimum? So if 13 is the minimum, I know 9 will stay where 9 is. If 13 is the minimum, 13 will come at the first place. It will. And if 13 comes here, where will 46 go? 46 will go to 13. So 46 goes here. And the rest remains as it is. Perfect. Step 2 done. Let's do step 3. So can I say, after 2 steps, I got the first two minimums. And this portion of the array is sorted. I can. Now we are left with this portion. What to do? Get the next minimum. Who's the next minimum? 20.
20. 20 को 24
As
से
usual,
करेंगे.
930 stays. 20 comes in. So if 20 is coming in here, where will 24 go? 24 will go to 20. So take it to there. And 50 to 46. At step 4, can you say that this portion of the array is sorted? You can. Which portion is not? This one. So in this, which is the minimum? 24. Place it. 9, 13, 20, 24. 52 goes at its place. 46. Let's do the step 5. Who's the minimum? 50. Now, at step 5, if this is done, do you need to do you need to sort one element? One element will always be sorted. So apparently, can I say the entire array is sorted at step 5? 1, 2, 3, 4, 5, 6, 6 elements, but actually took 5 steps to sort the entire array. What I did was get the minimum and swap it, the minimum and swap the algorithm. But how do I implement this in code? I'll be writing the pseudocode so that you can write it in C++ as well as in Java as well as in Python. So in order to implement algorithms, you have to.
So अभी इसने selection sorting बताया. Pretty easy, I believe. देखो. So it's easy कि first of all देखो ये हमारी एरे है. कुछ नहीं करना है, इसमें सबसे छोटा एलिमेंट हमें लेने पर सिलेक्ट करना है सबसे छोटा एलिमेंट एंड उसकी पोजीशन फर्स्ट वाले से स्वैप करनी है. रेस्ट ऑल सेम. नेक्स्ट अभी हो गया. नेक्स्ट पूरी एरे ओके वेट. नेक्स्ट अब पूरी की पूरी एरे में से सबसे छोटा एलिमेंट कौन सा है? 9 के बाद 13 और 13 की जगह क्या है? 46 और बाकी 24 52 20 सेम जगह. ठीक है, पहले ये चेंज हुआ था, अब ये चेंज हुआ. नेक्स्ट सबसे छोटा कौन सा है हमारा? 20 है ना, तब 20 को हम रिप्लेस करेंगे 24 से. हम्म, so 9 13 20. अब 24 को हम रिप्लेस करेंगे 24 को रिप्लेस करेंगे 52 से 46 और अब लास्ट स्टेप में हम इसको रिप्लेस करेंगे. दिस इज इट. इतना ही है टू बी ऑनेस्ट, पता है ज़्यादा है नहीं. Fine. No more disturbances, I guess. Next thing is
Have something like observing power. Let's start observing. What's the first observation? In the entire array, very, very important. In the entire array, we figured out the minimum. Can I say we figured out the minimum? And whichever index the minimum appeared, I swapped it with the first guy, 0th index. That's what I did. That's why 13 is here and 9 is here. So 0 to 5 is what I went. Next, I took this, which is from index 1 to index 5, and I got the minimum, which is 13, and I swapped it with 46. Thereby, I got. So I went from 1 to 5, and the swapping happened with 1 and the minimum index. Next, in this, I got the minimum, and the swapping happened from 2. So can I say first time swap happened at index 0 and minimum index. Next time swap happened at index 1 and minimum index. And this minimum index is from the array 0 to n minus 1. This minimum index is from the array 1 to n minus 1. Next time can I say swapping happened at index 2, because till that 0 and 1 are sorted. And minimum index this time is from 2 to n minus 1. So can I generalize this? And can I say this will go like 0, 1, 2 till what? Are you doing for the last guy? Are you swapping the last guy? It's just still here. You got 46 and you swapped. Can I say you'll go till n minus 2th index? Why n minus 2th index? Why? Because the last index is n minus 1 in arrays. So can I say, okay, swapping is happening 0, 1, 2, and it'll go till n minus 2. So thereby, can I write this as like this, the pseudocode n minus, okay, this is n minus 1. Swapping is happening x. You got 46 and you swapped. Can I say you'll go till n minus 2th index? Why n minus 2th index? Why? Because the last index is n minus 1 in arrays. So can I say, okay, swapping is happening 0, 1, 2, index, are you 0 happens and minimum happened at index 0 and minimum index.
Okay
Next,
guys, थोड़ा 5-10 मिनट्स का ब्रेक लेते हैं. Yup.